In this session, I will be discussing cardiac adaptations. So let's start cardiac adaptations. You know the heart cells, the cardiac myocytes, the cells which are present in the myocardium of the heart, they are terminally differentiated cell. Actually, in human body, there are three types of cells. The labile cells, which constantly divide, which can divide the mucosal cells, the bone marrow, hematopoietic stem cells. They keep on dividing throughout the life. The second type of the cells are the stable cells. They can divide if they are injured. Otherwise, in postnatal life, they don't divide. Like the cells of the liver, the cells of the kidney. If they are injured, they are able to divide. They can enter the cell cycle, but otherwise they don't divide. And the third type of cells are permanent or terminally differentiated cell. Even on injury, they don't divide. So basically, the terminally differentiated cells don't divide in postnatal life. So the cardiac cells, the cardiac myocytes are terminally differentiated cells. They are permanent cells. They can't divide. They can't divide. So you know how many type of adaptations you read in general pathology? It's hypertrophy, hyperplasia, metaplasia, dysplasia, atrophy. So hypertrophy is increase in size and hyperplasia is increase in number. For increasing in number, the cell has to divide. So you tell me whether cardiac myocytes can be able to do hyperplasia? No, they cannot undergo hyperplasia. They cannot undergo hyperplasia because they cannot divide, because they are terminally differentiated cell. So only adaptation they can do is hypertrophy. Hypertrophy means increase in size. They can increase their size in response to stress, but they cannot increase their number in response to stress because they are terminally differentiated cell and they cannot divide. Now, what is the stress on the heart? On the heart, there are two types of stress, because of which there are two types of cardiac adaptations, right? So, pressure overload or volume overload. What is the stress on the heart? I will be explaining you both one by one. Let's start with pressure overload. So, when the heart have pressure overload, can you see this is a diagram of heart? The complete cycle you can see. I guess you all can see. Just suppose there is an aortic stenosis. You know, aortic stenosis. The aortic wall undergoes stenosed. So what will happen if the aortic normally when the left ventricle is doing the systole, it's contracting, the blood is going in the aorta. The blood is going in the aorta. But now when the left ventricle is contracting, complete blood is not going in the aorta because there is stenosis. So the left ventricle require more pressure to push the blood into the aorta because there is stenosis. Either you say stenosis or there is hypertension, the systemic hypertension, one and the same thing. So it is causing a stress. So the stress, the pressure overload is aortic stenosis or systemic hypertension or bicuspid aortic wall, because of which there is aortic stenosis. So blood cannot be pushed from the left ventricle into the aorta because the wall is diseased. You got my point? So what the heart will do? So can you see the cells of the heart here? In the heart myocardiocytes, these are the cells. These are the cells in the myocardium of the heart. Now they will increase in size. They will increase in size to cause the thickening of the wall of the heart so that they can put more pressure while contracting, so to push the blood into the aorta, right? So they will increase in size, not number. They will increase in size, not number, in which they will increase their width but not length. They will increase their width, not length. And ultimately, it causes the thickening of the wall of the left ventricle. It is known as concentric hypertrophy. It is known as concentric hypertrophy, that is thickening of the wall of the left ventricle. So let me show you. Can you see here? If I am cutting the heart from here, and looking from above, what I will see? See the normal heart. What I will see? I can see the two cavities. This is right ventricular cavity. This is left ventricular cavity. I am interested in the wall of the left ventricle. This is the wall of the left ventricle. You got my point? Now, due to the pressure hypertrophy, due to the pressure overload, pressure stress, can you see here the wall got thickened? Now, compare this wall thickening with normal. This wall thickening with normal. So the wall got thickened. The wall got thickened. The lumen is narrowed. Can you see this is the lumen? The lumen is narrowed. Lumen is narrowed. The wall got thickened. This is known as concentric. It is towards the center. The lumen is narrowed. Now, why the wall is thickened? Can you tell me the reason for the thickness of this wall? Because the cardiac myocytes present here in the wall, they all increase in width, not in length. They increase in width. And such hypertrophy is known as concentric hypertrophy. Coming on the next, the volume overload. I hope you got it, right? In volume overload, like example, aortic regurgitation. Now, this time it's not aortic stenosis. This time it's aortic regurgitation. Let me show you in the same diagram. Okay, just a second. In the same diagram I'm showing you. Here you can assume the aorta is regurgitating. That is, during systole, the blood is going well. But during diastole, the aortic wall should close and the blood should not come back. But during diastole,